In this video, we will be solving Math Applications SL, Paper 2, May 21, Time Zone 1. Let's get started. Question number 2. The diagram below shows a circular clock face with center O. The clock's minute hand has a length of 10 centimeter. The clock's hour hand has a length of 6 centimeter. At 4 p.m., the end point of the minute hand is at point A. The end point of the hour hand is point B. Find the size of the angle AOB in degrees. AOB. We need to find the size of this angle. So, to find the size of this angle, we can see that if this full circle is 360 degrees, this can be formed by 1, 2, 3, 4 parts here, 4 angles. To find the size of each of those angles, so we know it's 12 hours. Any clock here, it's 12 hours, so we will divide 360 divided by 12. So we are finding the size of each of those angles, each hour, and then multiplied by 4. So 1, 2, 3, 4 angles. Each of them is the size of 1 hour angle. So 360 degrees divided by 12 hours multiplied by 4, and this is 120 degrees. Then B, find the distance between points A and B. We need to find this distance. So now we can see it's triangle. This triangle, we know 10 centimeter this side, and this side is 6 centimeters, and we know this angle is 120 degrees. So to find the side AB, all what we need is to use the cosine formula from the formula booklet. AB squared, this side squared, equals the second side 10 squared plus 6 squared minus 2 times 10 times 6 cosine 120 degrees. So when you calculate, you will take the square root, you will get AB equals 14 centimeters. So this is the side length of AB. Between 4 p.m. and 4:13 p.m., the end point of the minute hand rotated through an angle theta. So this is the minute hand rotated through angle theta from point A to point C. This is illustrated in the diagram. So this formed by this minute hand from 4 p.m. till 4:13. That's why here C is in the 13th minute. Question C, find the size of angle theta in degrees. So, because this is 13 minutes, so we will do the same as what we did in question A, that we will find the size of the angle formed by 1 minute. So 360 degrees, this is the full circle, divided by 60 minutes. So this is the angle of each minute. Then multiplied by 13 equals 78 degrees. This is the angle theta. Calculate the length of arc AC. This arc here, we need to find this length of the arc AC. So we can see in the formula booklet that arc length L is theta over 360 times 2 pi r. Theta here, this is the 78 degrees. So L equals 78 degrees over 360 times 2 pi r. Here the radius that we are using, this is 10 centimeters. So this is the radius. Here this is 10, this is 10. So this is our radius. So this is multiplied by 10. When you use the calculator, and we will get 3 significant figures, 13.6 centimeters. This is part D. Part E, calculate the area of the shaded sector. So we need to find this area. So also in the formula booklet, area equals theta over 360 times pi r squared. We will substitute. So 78 over 360 times pi 10 squared. And this will be 68.1 centimeter squared. This is 3 significant figures. And this is the answer of part E. Done. A second clock is illustrated in the diagram below. The clock face has a radius 10 centimeter. So here is the radius 10, with minute and hour hand both lengths of 10. So this is 10, this is also 10. Minute and hour both the same length. The time shown is 6 a.m. So this is here, this is 6. The bottom of the clock face is located 3 centimeters above the horizontal bookshelf. So the distance between the bookshelf and here is 3 centimeters. F, write down the height of the end point, the height of the end point of the minute hand, this is the minute hand, above the bookshelf at 6 a.m. So this is 6 a.m. The height above the bookshelf is 10 plus 10 plus 3. So 10 plus 10 plus 3, it's a 23 centimeter, the height of this end point of the minute hand above the bookshelf. The height, h centimeters, of the end point of the minute hand above the bookshelf is modeled by the function. Here is the function. So h represents the height of this end point of the minute hand above the bookshelf. So we are using this function to calculate the height above the bookshelf, where theta is the angle rotated by minute's hand from 6 a.m. So when this minute hand will start moving, it's forming theta. So this is our theta here. So G, find the value of h when theta is 160. So what we need is to substitute theta with 160. H equals 10 cosine 160 degrees plus 13. Using the calculator, we will get h equals 3.60, 3 significant figures, not 3.6, 3.60 centimeters. The height g centimeters of the endpoint of the hour hand above the bookshelf is modeled by this function. So now we are talking about the hour hand above the bookshelf. And where theta is the angle in degrees rotated by the minute hand. So theta here is the angle rotated by the minute hand still. So this is the same theta that we are using, and we are using this theta to calculate the height for the hour hand. H, write down the amplitude of G of theta. So we know that a function in this form here, cosine function in this form, the amplitude is the number in front of the cosine. This is what we call it A. So amplitude is the absolute value of this A, which means absolute value of -10, which is +10. So this is the amplitude of this function. Then the endpoints of the minute hand and hour hand meet when theta equals k. Theta equals a number. So this minute hand and hour hand, they meet when theta is k. Find the smallest possible value of k. So when we are talking about these two hands of the clock meeting at specific theta, so this means we need to find the intersection point. When they are meet, so they are intersecting. So we need to find the intersection point, which means we will equate h of theta to g of theta. So we will write 10 cosine theta plus 13 equals -10 cosine theta over 12 plus 13. Now we have two ways to find this angle theta, or k, the value of k. The first way, insert this equation into the graphing calculator in equation solver and find the value of theta. And of course, when you insert this equation, theta will be your x. Some calculators will not be able to solve this equation, and you will not get a valid solution. So the other way, which is suitable for all calculators, is insert this into graph. So you will have this y1 and this y2, and then graph. When you graph, you will find the intersection between these 2 points, because this is what we need. This is our value of theta. This is the x in your calculator. So when you will find the intersection point, the smallest possible intersection point, the first intersection between these 2 angles, you will get theta equals 116 degrees, which is k equals 100. We will get theta equals 196 degrees, or k equals 196. This was the answer of question number 2, and you will find in the description below, the description box, you will find all my social media accounts. You can send me all your questions, and of course I will be happy to receive all your comments. I will reply to all your comments if you have any questions, and please don't forget to like and subscribe, and see you next video. Goodbye.